In this video, I will go over the homework that follows lecture 20.1 that introduces the unlimited population growth model. And as always, I hope that you watched the following lecture, and let's go ahead and jump right into the homework. In problem 1, we have been provided with a differential equation that describes the growth of what is that we're talking about here? Bacteria. And the good news is that we don't have to solve this equation because the solution will always be the same. So we only have to solve this once. So this is the solution of this differential equation, where P0 is the initial population, R is the growth rate, and T is T is the variable, represents the time. So in our problem, P0 is given, R is given, and the question that we are asked to answer is this: find P of 3. And we have to take advantage of the fact that we live in 21st century. So let me show you how we can do this problem using this simple technology. So we define a function P of t, P0 e to the power RT, and we introduce these parameters. P0 is 7482, R is 0.01, and sometimes it makes sense to specify that t is greater than or equal to 0. And this is the graph that represents the growth of this population. As you keep zooming in, you're going to see that since there is no any constraint, then this population will just continue to grow. Now that we entered all the parameters, we are ready to answer the question. And the answer is approximately 7709.86, but we're going to round it, I believe, up, because bacteria can only be counted as integers, and this will be the answer. So if you understand the idea, it's the topic is pretty straightforward. Like once we remove all the tedious computations, you can actually enjoy working with this model. So we have another one. I'm just going to write the model, and what's given and we are asked to find P of 2. So I'm going to open my Desmos model here and just enter everything, just like that. So if we have to round to the nearest, not to the nearest, but to the next highest integer, I guess that's the right way to say it, then that would be the answer. I don't even know what to say here. It's that easy, right? So we have a model. We input the model into some computational device, and then we ask the computational device to do all the computations for us, and we just interpret everything. So that's all there is. I'm just sad that all we're talking about here is bacteria, when in real life we could be talking about anything. So any population that doesn't have any constraints. So again, as we say bacteria, you can think of something else growing uncontrollably. If you look at the solution, I think what makes it less appealing is the fact that they assume that we don't have access to technology. It does compute or do all the computations by hand. So we finished this homework. It was nice and easy. If you have any questions, feel free to reach out.